last problems. We're doing problem 4 and, page 4, okay, front and back. Okay, and so this problem is asking us to find the exact solutions with no decimals, which basically just means solve, right? So for this problem, it's already set up for us, and we can solve this one. If I see a squared, I want it to be set equal to 0, so I'm going to subtract 5 on both sides, and it's going to become negative 2x squared plus 3x minus 11 equals 0. And so they're asking for exact answers. So I'm looking at this one, and I'm saying it doesn't look like it factors because I don't know anything that multiplies to 22 that adds up to 3. So I'm going to use the quadratic formula. So negative 3 plus or minus 3 squared, which I'm just going to write the 9 version of that, 4 times a times c, all over 2a, which is for us 2 times negative 2. So we need to simplify this. Oop, that's x. I'm still stuck in the last mode problem. All right, so this is x. And so we just need to simplify this, and they ask for the exact solution, which means we're not going to take the square root. We're just going to simplify our radical. So this is negative 3 plus or minus. This says 9 plus, it looks like it says 88, right? This is 4 times 2 is 8. 8 times 11 is 88, right? So this says 9 minus, right, 88 underneath the radical. 9 minus 88, excuse me, 9 minus 88 is 79. So this is the square root of negative 79 over 4. Okay, so 79, fortunately for us, doesn't have any perfect squares in it, but we do need to get this negative 1 out of the radical, which, remember, the square root of negative 1 is I. So my final answer here is negative 3 plus or minus I times the square root of 79 all over 4. And this would be the most simple version. Again, we're not square rooting 79, not getting any decimals. We're going to leave it in radical form. Okay, so letter B is exactly the same, so we're not going to do letter B. We're going to move on to problem number 35, which is now working with I and being able to simplify them. So we'll do a couple of these. Okay, first problem is asking us to multiply together these two complex expressions. So this is just FOIL to start. So we're going to say 5 times 2 is 10. 5 times negative 4i is negative 20i. 3i times 2 is positive 6i, and then 3i times negative 4i is negative 12i squared. Right? So let's do a little combining. The 10 I'm going to leave alone. This is negative 14i, okay? And this is negative 12, and I'm not going to write I squared because I squared really means something. It means negative 1, because remember, I is equal to the square root of negative 1. So that means that I squared is equal to just regular old negative 1 if I square both sides. So I can simplify this a little bit more. This really says plus 12, right? Negative 12 times negative 1 is positive 12. So this says 10 plus 12, or 22, minus 14i. Okay? So the rest of your problems on this are pretty much the same concept. If I do 2i times 7, I get 14i. And if I do 2i times I get 2i squared. But we're not going to leave it as 2i squared. We're going to say that's really negative 1. So this is 14i minus 2, which you may see written in standard form. Usually we write the real number first, okay, and the complex number second. So this is what's called a plus bi form, or standard form, right? And letter C I'm not going to do because it's the same thing as letter A, but I'm just going to remind you that squaring 9 plus 8i really means the same thing as 9 plus 8i times itself, 9 plus 8i. So be careful that you don't, again, just square the parts of that one, that you do FOIL everything out. Problem 36 is asking us to do a lot of things, so let's take them step by step. It says identify all of the information for this function f of x. So we're going to start out by finding the x-intercepts. Remember, if we look at a graph, right, or a coordinate plane, x-intercepts are things along the x-axis, and all of these points, anywhere you go, are going to be some x value, but the y value is 0 for all of them. And so I know that I can plug in a 0 here. So it's going to be 0 equals negative 2x squared plus 6x plus 8, which, nice for us, negative 6x squared, negative 2x squared plus 6x plus 8 divides. So I'm going to divide everything by negative 2, because if I can make this be 1, it maybe will factor simply. So I'm going to say 0 equals, if I divide this one by negative 2, I get x squared. If I divide 6 by negative 2, I get negative 3x. And if I divide 4 by negative 2, I get, 8 by negative 2, I get a negative 4. Which for us, again, this is nice. This factors very simply into x minus 4 and x plus 1. And I would say I'm going to get 2 zeros out of this. I'm going to get a 0 at positive 4, so I'm going to say 4, 0. and negative 1, so my other x-intercept is negative 1, 0. Okay? They want to know what the y-intercept is. The y-intercept is the opposite. So if I go back to my graph here and I plug in something on the y-axis, anywhere that I go, it's going to be some 0 in the x spot and then whatever the y value is. So I know that x is 0 for every y-intercept. So if I plug in a 0 into this function, this will all become 0. This will all become 0. And it's going to say 0 plus 8. Well, that would just be the end value, which is 0, 8. So my y-intercept is at 0, 8. 3 is asking us about the vertex, and we've done the vertex. We did that with our vertical motion problem, so this shouldn't be that bad. Okay, so we're going to say for this problem that we want to do negative b over 2a. So we're going to come off to the side and say x is equal to negative b over 2a. Right? And so for us, b is 6, so I'm going to say negative 6 over 2 times negative 2 would be negative 4. And this simplifies just to 3 halves, which I'm going to use the fraction or the decimal version of that. It'll be a little bit easier to plug in, 1.5. So I know that this is at 1.5, comma, right? And when we plug this back in, right, I'm going to let you go through and plug it in. When you plug it back in, you get 12.5, right? So if you're careful with your parentheses, right, and when you're plugging in, you get a value of 12.5 coming out of the function. If I plug in 1.5 for x squared and for x, and I simplify f of x, I will get a 12.5. So I'm going to say the vertex is there. So let's take a look at the last part, which the last part is asking us to describe the interval that is for increasing and decreasing. So I'm going to just sketch what I know about this so far. All right, I know that this has an x-intercept over here, kind of somewhere at 4, and it's got another one really close to the y-axis at negative 1. And then if I go over to 1.5 and I go up to 12.5, which would be way up here somewhere, that's where the y-axis, I'm sorry, where the vertex is. And then at 0, 8, which would maybe be in here somewhere, that's where my y-intercept is. So if I sketch this, again, this is just a rough sketch, definitely not accurate, right? But it gives us a rough idea about what my picture is going to look like, right? So when they ask about the interval of increasing, I'm going to say that this graph is increasing on the left-hand side, right? It's kind of going up here until it hits the vertex. So the way that I would describe intervals, when we're describing intervals, we're describing the x values on which it's increasing. So I'm going to say it's increasing from, okay, negative infinity, okay, so the left-hand side of the graph over here is negative infinity on the x-axis, and it keeps increasing from negative infinity all the way up until this point here, and that's the vertex. The x value of the vertex is 1.5, okay? So I'm going to say negative infinity, comma 1.5, and this is not a point, be careful, this is what's called interval notation, which is describing the beginning and the end of a section of the graph, right? So I can do the same thing where decreasing, I'm saying it's going to decrease on the right hand side. After it gets to the highest point, it's going to start heading down now. And so I'm going to say, starting at 1.5 on the x-axis, right, which is where the vertex is, comma, it's going forever. So we would call that positive infinity because the right-hand side of my graph is positive infinity. So I would say this goes from 1.5 forever up to infinity on the x-axis. So this would be how I would describe the interval increasing and the interval decreasing using interval notation. Problem number 37 is asking us to take a look at this graph, compare it to the parent function, and describe any transformations that are happening. Okay, so the first thing that I'm going to do is I'm going to graph my parent function because it was not provided to us. So if I just plug in some values, if I plug in 0 here, I get 0 squared, which is 0. If I plug in a 1, I get 1 squared, which is 1. If I plug in a 2, I get 2 squared, which is 4. And now it looks like I'm going too high off my graph, so I won't go any further. If I go to the left-hand side and I do negative 1 squared, I get 1. And if I do negative 2 squared, I get 4 as well, right? And so this would be my sketch. So let me see if I can kind of accurately sketch this one. We want to be as accurate as we can be. All right, and so my job is to list the transformations just using words, okay? And then write the equation for my new graph. And then I want to talk about what is the sum of a plus c plus d, which we'll do in a second. So let's just list the transformations. So I'm going to start off with the easy ones, what I'm claiming are the easy ones, which are the slides. I'm going to figure out how did I get this vertex of 0, 0 down to where it is in the new function. And so we are going to say it looks like it moved to the left by 2 and it moved down by 4. And so remember, left and right, to move left, my c would have to equal negative 2, and down, my d would have be equal to -4. So I found 2 of the values. They're saying that I should be able to find A, C, and D. And so the last one is we have to figure out A. So remember, A does 2 things. It does reflections, and it does stretches or compresses, depending on what the value is. So if you notice, this one is not reflected up and down at all. It still has an opening up, just like the original. So A is positive. We didn't switch that, which means there might be a stretch going on here. So here's how we're going to find out. I'm going to compare the vertical distance. If I'm talking about A, I'm talking about the vertical change, right? So I would measure from this point up to the next set of points that I graphed my parent function. I would say that is 1 unit up. Okay? If I were to compare that to my next graph, right, here's kind of where the nice grid points are. That is now 3 units up. Right? And if I do the same thing going to another grid point, let's see if we have another nice grid point. We don't have another nice grid point here to check. So I can just use these ones. And we're going to say it looks like the vertical distance between my vertex and my first set of nice grid points here increased from 1 to 3. So it is 3 times larger than it used to be. So I would say that this was a stretch. Right? It got longer up and down by a factor of 3, which means my A value has to be 3. So my equation for this one is going to be, remember, if I'm using this format up here, my A value I'm just plugging in and saying f of x is equal to 3 times x. If I plug in a -2 here, it's going to turn into x plus 2 squared, and then -4 for my D value. And so now they're just asking for the sum of these values. This is going to be 3 plus -4 plus -2, right? Let's just do notation properly. So that looks like -3 when I'm all said and done, because this is -6 plus 3, or -3. Okay. So again, the A value is a little bit trickier, but just kind of look for vertical changes. I can say that a 1 unit up turned into a 3 units up, and so that would be an A value of 3 to stretch it out. Okay, and that's it. We're done. Okay, the rest of the problems are duplicates of everything that we've done, and so you know everything you need to know to pass your midterm exam.